So now we're going to get into exponential functions. So exponential functions are a little bit different than polynomials. Personally, I don't think they're. I think polynomials might be trickier, or at least can have more involved in working with them. Exponential functions, once you kind of get used to them, are not too bad. So let's just look at a definition here. So we have exponential function with base a is defined as f of x equals a to the x. And a has to be a positive number. A cannot equal 1. Now, the reason a cannot equal 1 is because if you had f of x equals 1 to the x, then it doesn't matter what x is. F of x is just 1. So not exponential in that case. Now, what does the graph look like? An exponential function looks like this. If, so y equals 2 to the x, or if y equals 2 to the negative x, it looks like this, where it's going down from left to right. So 2 to the x goes up from left to right. 2 to the negative x goes down from left to right. Now, we could also rewrite this one as 1/2 to the x. So if you remember exponent properties, if you have, say, 5 to the negative 2, that's the same as 1 over 5 squared. So 2 to the negative x is the same as 1 over 2 to the x, which is also the same as 1/2 to the x. So as it turns out, if a is greater than 1, we are here. If a is between 0 and 1, then we are here. And so a greater than 1, the graph will always look something like this. It'll have this shape. If a is between 0 and 1, it will have this shape. So something to keep in mind there. When we look at other types of exponential graphs, different variations, again, the same translations and reflections still apply. So if we put a negative in front, that will reflect over the x-axis, like we have said before. So reflect over x, and you can see this one is flipped. So we have 2 to the x, negative 2 to the x. We're just going to flip that over. So it would look like that. Then the +3, we're going to shift it up 3. And so that's where that comes from. Now, a couple other things to point out, and this goes with all the exponential functions. As long as you just have an x and you're not getting into anything strange like 2 to the 1 over x, where 1 over x is in the exponent, or 2 to the square root of x, anything like that. So as long as we're just doing 2 to the x, or any other type of polynomial, the domain of these is going to be all real numbers. The range of the basic ones, and so by the basic ones, we're talking about either of these two, where the base could be any valid base, but we either have x or negative x, and really just x, because again, you can write this one with x as the exponent. So the range of the basic one is 0 to infinity. Now, once you start reflecting and shifting up or down, obviously this will change, but the domain will not change. The range may change based on what you've done to the graph. Then you can also see, you can see it clearly here, we have a horizontal asymptote. Here we have one, it's not really marked, but we have one going through the x-axis. So there is a horizontal asymptote that we talked about in the last section at y equals 0. And then, of course, if you move it up or down, that's going to move the horizontal asymptote. But you will always have one in these basic exponential functions. All right, so let's see what else we have. Exponential property of equality. So this is talking more about solving equations. And we'll do a little solving equations. But again, calculus is more about looking at graphs and different properties and how they're behaving and things like that. But we'll solve a couple of here. So if a is greater than 0 and a is not equal to 1, so in other words, a valid base. So this is a valid base to the exponential equation, and we have a to the x equals a to the y. Then x equals y. So if you can get the bases equal, the exponents are automatically equal. So very simple version of this, if we have 3 to the x equals 3 squared. Obviously, 3 squared is 9, but the bases are the same, so we have x equals 2. So that's the idea, and that's with basic exponential equations. A lot of times, that's how you're going to be solving those. Case in point, we have this one, 25 to the x over 2 equals 125 to the x plus 3. And so these do not have the same base, so we cannot say that x over 2 equals x plus 3. So that doesn't work because these are not the same base. But could we write them as the same base? So it certainly helps if you can quickly think of what number can you raise to an exponent and get 25 or 125. And in this case, obviously 5 squared is 25 and 5 cubed is 125. So it helps to, if you can do those quickly, it helps. And they're not going to be big numbers. We're not going to have huge numbers in these equations. So knowing your basic squares, such as 2 squared, 3 squared, 4 squared, so on up to probably 10 squared. And then 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. 5 cubed is 125, and probably that's enough. 6 cubed is 216, but probably those are enough. If you have these memorized, then probably you'll be able to do any of these that they throw at you. So we can rewrite this as 5 squared to the x over 2 equals, and 125 is 5 cubed to the x plus 3. Now, if you remember properties of exponents, if you have a to the m and that is raised to the n, that is the same as multiplying the exponents. And you could test this out if you have 5 squared to the 4th, that's going to be the same as 5 to the 8th. And you can check that in the calculator and see that it works. So now we just need to multiply these two. So 2 times x over 2 is just x, so we have 5 to the x, and then 3 times x plus 3, we have 5 to the 3 times x plus 3. Now our bases are the same, so our exponents are going to be equal. So x equals 3 times x plus 3. So we get x equals 3x plus 9. We can subtract the 3x, so we get negative 2x equals 9, and x equals negative 9/2. And so that's the basic idea with these in this section. We're not learning about logarithms till the next section, where things get trickier, maybe not trickier, but a different way to solve them. We'll just say that. I don't know that it's trickier, but these are pretty basic. If you can get your base the same, then things become very easy after that. All right, then let's talk about definition of E, and then I'm going to go over to my math lab and show you how to graph on there. So the definition of E, so E is a number kind of like pi. E is an irrational number, so as m becomes larger and larger, 1 plus 1 over m to the m becomes closer and closer to the number E, which E is defined as this number. So whenever you see E, it's like when you see pi, you think 3.14. You see E, you think 2.718. And you can put that in the calculator and go from there. But I'm sure you've seen that. So let's go over here to my math lab. And because these are, I don't know if these are obvious to graph on my math lab. So let's look at this one. So this is graphing y equals negative 4 e to the negative 3x minus 1, and e is just the base, so it doesn't really matter for us, I guess, too much when we're just graphing in my math lab. So click to enlarge the graph, and then you've probably done this on some other homework assignments, so this probably isn't completely new, but you can always read up here and it'll tell you kind of what to do. So choose a tool in the palette, follow the instructions. So which type of function is this? It's exponential. And it helps if you know the basic shape, but if you don't, you can hold your mouse over and it'll say this is for the linear, this is for the logarithm, and this is for the exponential, and nothing else you really have to worry about. These are for inequalities, which we're not doing. That's for these three are all for inequalities, which we won't be doing in this class. So now, click the graph to plot your curve. You can click anywhere, and it will show you the basic e to the x function. So now we have these options for the stretches or the shifts or the reflections. So you just have to tell it which ones you want to do. So we have the negative in front. So that's going to reflect over the x-axis. We have the 4. So we didn't talk about this one, but when you put a number in front of the basic function or the parent function, that's going to be a vertical stretch. So now you just move this over and you can see it's changing the number, and you want to put that at 4. Then we have -3. Now this is inside the parent function, so that negative is going to be a reflection over the y-axis, and the number up here inside the function is going to be a horizontal stretch. So now put that at 3. So the number in front of the function is a vertical stretch. The number inside the function, when we're multiplying, we're talking about stretching. So the number inside the function will be a horizontal stretch. And then we got the -1. Of course, we know that's going to shift down. So go over to the -1, and that is what we end up with. So hopefully that is correct. And check your answer, and there you go. So, so I just want to show you that just in case don't have any confusion on that. But obviously, if you see this one on the test, you would have to draw it by hand. And I would suggest do like I've done in other videos where you go step by step. So you draw the basic e to the x, and then you can reflect it, and then you can stretch it. And so you draw several graphs until you end up at the end. So, okay, so we'll stop there and pick it up in the next section next time.